Let's assume that you have an object sitting at a certain height above the ground. Height can be anything that you want it to be in meters. But we want to drop this ball. And as we drop this ball, it's going to fall until it reaches the ground. What we're wondering is, what is the velocity of the ball right before it impacts the ground? We can look at this by observing the law of conservation of energy, where the energy before equals the energy after. And you can tell just by looking at this diagram that the potential energy in this ball should be equal to the mass times gravity times the height. This is because the ball is initially at a certain height and it's going to drop. So it's going to be the force of gravity that is pulling it down. The force of gravity multiplied by mass gives you a force. So, again, looking at this, you can also tell, and this is the potential energy, you can also tell that this object has absolutely no kinetic energy. The kinetic energy is equal to 0. This is because the only thing that the ball can do is go down. The ball can no longer go up because we are dropping it from this height. We're not throwing it in the air, we're simply dropping it. So the kinetic energy is 0. So for the beginning, energy is all potential energy, which will give us mgh. And this is our energy before we drop the ball. Now the energy after we drop the ball is the final energy. And we're going to say that that is all kinetic energy. Because once you change, this kinetic energy is then going to equal this spot right here. The kinetic energy, as in an equation, is equal to 1/2 the mass times velocity squared. And at this point, right before it hits the ground, our potential energy is now 0. So you can see you have an energy before and an energy after. Plugging that in, our energy before, mgh, is equal to our energy afterwards, which is the kinetic energy, 1/2 mv squared. Back to our question, what we're looking for. We're looking for the velocity just before it impacts. So the velocity right here, v, is what we're looking for. And we're going to have to figure that out. And we can do some algebra for that. So, mgh equals 1/2 mv squared. And again, we're looking for this. So multiplying both sides, I'll do this for y'all. Multiplying both sides so you can see. Dividing both sides. What you're going to get is 2gh is equal to v squared. Now, we still need to figure out what v is. So, taking the square root of both sides, you get the square root of 2gh is equal to the velocity. And then plugging in numbers, you will find your velocity just before it impacts.